What you are about to hear is not speculation, music, nor is it entertainment-driven science. It represents the most significant music structural development since this object was first identified approaching the inner solar system. New high-resolution orbital data has just been released, and what appears inside these images is not another blurry coma, not another random cloud of dust and gas, but a geometry so music precise, so mathematically rigid that it pushes directly against the limits of standard comet physics. At first glance, everything looks normal. The familiar diffuse glow, the bright halo, the soft cloud of scattered light that we've seen thousands of times before. But that glow is a trap because the real structure, music, is hidden inside the brightness. When astronomers removed the symmetry, stripped away music, the circular noise, and peeled back the light like layers of fog, what emerged was not chaos, not turbulence, not random outgassing, but order, a pattern, a structure, a configuration that should not exist in a music thermally stressed natural body. Last week, a rare alignment removed the last major projection distortions, giving us music, the cleanest geometric view of 3I atlas we will get during this entire encounter. Whatever this music object truly is, the next data window may change the entire interpretation of what we are observing. In raw images, music 3I atlas looks exactly like what physics predicts. A bright coma, a diffuse halo of dust and gas. Music, a glowing cloud created by sublimating ice and solar heating. The same visual signature seen in thousands of cometary observations. But that brightness, music, is optical camouflage because it hides structural information. To isolate what actually defines the object, astronomers applied a rotational, music gradient processing method, a filter designed to mathematically cancel anything that is perfectly circular and symmetric. Conceptually, it's simple. Rotate the image, subtract it from itself, and everything, music, that is naturally round disappears, leaving only what cannot be explained by symmetry. When this filter was applied, the coma vanished, and what remained was not randomness, but geometry. 3 perfectly defined mini-jets, music, arranged in a symmetric triad, separated by exactly 120 degrees. Not approximate symmetry, not visual suggestion, but rigid angular separation. The kind of geometry that does not emerge naturally from chaotic sublimation patterns. This was not a single-frame anomaly either. The same processing music method was applied across multiple high-quality observation sets taken over nearly 2 months spanning late November, December, and January. And in every single data set, the same triadic structure appears with the same angular separation, music, the same symmetry, and the same stability. This persistence, music, transforms the pattern from coincidence into structure. Because natural cometary activity under thermal stress is chaotic, fractures open and close. Jets shift, activity migrates. But here the geometry does not change. It remains anchored, rigid, stable, as if it were part of the object's internal architecture rather than a surface accident. The geometry does not stop at the triad. Processing reveals a fourth structure, music, morphologically different from the other 3. A dominant, elongated jet extending in the solar direction far longer and more powerful than the mini-jets forming a clear axial feature. The final configuration becomes highly specific. 3 short symmetric jets spaced at 120 degrees plus 1. Music, dominant solar-directed structure. In standard cometary physics, jets are created by localized sublimation pockets that turn on and off as regions rotate into sunlight, producing irregular patterns, spirals, flickering arms, and chaotic changes in morphology. If the nucleus, music, rotates, jets should shift, migrate, and evolve dynamically. But this system does not behave like that. The stability of the triad across weeks of observation. Music implies that the emission points are anchored in fixed structural positions, not transient fractures or random volatile pockets. Even more unsettling, is that we are not observing a three-dimensional structure directly. We are seeing a two-dimensional projection. For random 3D jet distributions to repeatedly project into perfect 120-degree symmetry across changing observation angles as Earth and the object move through space would be statistically absurd. The repetition implies intrinsic geometry, meaning the symmetry is part of the object itself, not an artifact of viewing angle. This transforms the interpretation from surface activity to internal structural organization. Because symmetry that persists through motion and changing geometry is not visual coincidence. It is physical configuration. Jets are not just visual features. Music are forces. Every kilogram of material expelled generates reactive impulse in the opposite direction. Three symmetric jets, music, plus one dominant jet create a complex torque system acting on the nucleus. In a natural rubble pile comet, this should destabilize rotation, alter orientation, and produce chaotic changes in spin behavior. Instead, analysis of jet motion over time reveals rhythmic oscillation, not chaos. A periodic wobble pattern consistent with precession rather than instability. The reconstructed motion defines a rotational period of approximately 7.1 hours, giving us an internal clock for the object. This is not random tumbling. Music is structured motion. The jets behave like inclined beams rotating through space, tracing conical paths rather than random spirals, producing a rhythmic balance that suggests controlled rotational dynamics rather than thermal disruption. Even more striking is the inferred orientation of the rotation. Music axis, which appears to be aligned close to the solar direction within a narrow angular range. This alignment had previously been hypothesized from light curve modeling, but now it is being supported by direct physical motion of expelled material. When mathematical inference aligns with physical morphology, confidence increases dramatically. For an object of this size, a 7-hour rotation period produces significant centrifugal forces. If 3I Atlas were a loosely bound aggregate, this rotational energy combined with sustained jet activity should drive fragmentation, structural failure, and morphological instability. Instead, the object remains coherent, stable, and structurally ordered, which introduces a serious mechanical contradiction within music standard comet models. Now music reached the most critical point. On January 22, 2026, a rare geometric alignment occurred in which the Earth-object-Sun geometry became nearly collinear, reducing projection distortions, music, to near minimum. In practical terms, this alignment removes much of the visual ambiguity that normally complicates interpretation. During this window, structural symmetry becomes more honest, less music distorted by perspective. If the triadic system is real and intrinsic, its geometry should appear more clearly, potentially forming ring-like or circular symmetry patterns instead of distorted projections. At the same time, the opposition effect enhances visibility as back illumination reduces shadows and increases signal-to-noise ratio, making faint structures more detectable. Weak features become brighter, edges become sharper, and fine structural details emerge. If substructures exist within the jets, this is the window where they will appear. This is not theoretical speculation. It is an observational countdown. Less than 24 hours from now, the cleanest geometric view of the entire encounter will occur. After that, the object continues outward and observational clarity decreases. This alignment transforms the debate from interpretation to testable geometry. If the structure persists under these conditions, the conversation changes from what does it look like to what does it maintain under maximum clarity. And that distinction is everything in science. One of the most uncomfortable aspects of what music we are seeing is not the symmetry itself, but the fact that it survives conditions where symmetry should collapse. As 3I Atlas passed through perihelion, it experienced extreme thermal stress, uneven solar heating, and rapid changes in sublimation. Music pressure. In standard comet behavior, This is when everything falls apart. Fractures propagate, jets, music, migrate. New vents open while old ones shut down, and morphology becomes unpredictable from one observation to the next. But across nearly 60 music days of data, through multiple thermal regimes and changing illumination angles, music, the triadic jet system, remains intact. The 120 degrees separation does not drift. The relative intensity of the mini-jets does not randomize. Music, this persistence suggests that the jet sources are not surface accidents, but are deeply anchored within the body. In physical terms, this implies internal structural coherence strong enough to resist both thermal cracking and torque-induced drift. That alone places 3I Atlas outside the expected mechanical behavior of loosely bound icy bodies. A key detail that cannot be ignored is that every image we analyze is a two-dimensional projection of a three-dimensional system. This matters because random jet distributions in three-dimensional space almost never project into perfect symmetry repeatedly over time. As Earth, the Sun, and 3I Atlas move relative to one another, the viewing angle changes continuously. If the jets were randomly placed fractures or volatile vents, their apparent angular separation should fluctuate, distort, or collapse into asymmetric music patterns as perspective shifts. Instead, the 120 degrees geometry remains stable across observation epochs. This consistency implies that the jets are arranged in a real intrinsic music geometric configuration, likely organized around a rotational axis or a stable structural plane. In other words, the symmetry is not something we are seeing because of where we are standing. Music, it is something that exists regardless of where we observe it from. That distinction is critical because projection, music, artifacts disappear under changing geometry, while intrinsic structure does not. In commentary, music, physics, jets are often treated visually as features to be mapped or classified. But dynamically, jets are engines. Music, each jet produces momentum transfer, generating torque and altering rotational state. With three symmetric jets, music, and one dominant jet, the torque system becomes highly complex. In a natural scenario, such a configuration should lead to rapid changes, music, in spin rate, axis orientation, and jet alignment as feedback loops. Music destabilize the system. But what the reconstructed motion shows is not runaway behavior, but controlled oscillation. The jets sway together, maintaining relative geometry while the system undergoes periodic precession. This suggests a balance between impulse forces and internal mass distribution. Music, the object behaves less like a tumbling fragment and more like a rigid body with a predictable response to applied music forces. This is where comparisons to engineered systems become unavoidable. Not because anyone claims artificial origin, but because the physics overlaps. When dynamics resemble solutions to classic stability problems rather than chaotic failure modes, the correct scientific response is not dismissal, but deeper scrutiny. The emergence of approximately 7.1-hour rotational period introduces another serious constraint. For an object of this size, rotating that quickly while actively expelling material should push it towards structural failure, especially if it were a rubble pile held together primarily by weak gravity. Centrifugal forces scale with rotation rate, and combined with sustained mass loss, this should promote fragmentation or at least visible deformation. Yet no such breakdown is observed. The nucleus remains coherent. The jet geometry remains stable, and the oscillatory motion repeats rather than degrades. This implies either a level of internal cohesion far beyond what is normally assumed, music for cometary nuclei, or a mass distribution that counteracts destabilizing forces. Either option challenges existing models. A body that can rotate, music, rapidly, sustain asymmetric outgassing, and preserve macroscopic symmetry over weeks is not behaving. Music like dirty ice loosely stitched together by gravity. It is behaving music like something organized, mechanically resilient, and dynamically balanced in a way that standard comet classifications struggle to explain. At some point, science stops asking music whether a single observation is strange and starts asking whether the pattern itself, music, has become diagnostic. One anomaly can be dismissed as noise. Two can be coincidence. Music, but when multiple independent irregularities stack on top of each other and persist under stress, probability becomes part of the evidence. In the case of 3I Atlas, music, the symmetric triad, does not exist in isolation. It appears alongside sustained, non-gravitational acceleration that resists standard outgassing explanations, a persistent anti-tail structure, unusual polarization signatures, music chemical behavior that shifts before and after perihelion, and now a macroscopic, music geometry that remains stable across weeks of observation. Each of these features alone could be rationalized with ad hoc explanations. But taken together, they form a cumulative burden that simple models struggle, music, to carry. This is where statistical reasoning becomes uncomfortable because the question quietly, music, changes from can nature do this once to how often should nature do all of this at the same time. When the answer trends toward almost never, the responsible response is not to jump to conclusions, but to acknowledge that the current classification may, music, be incomplete. Nature is perfectly capable of generating symmetry, but context matters. Symmetry thrives at music, microscopic scales in crystals, molecular bonds, and fractal growth patterns where energy minimization dominates. At macroscopic, music scales, especially in thermally stressed rotating bodies actively losing mass, symmetry is fragile. It breaks easily, deforms quickly, and snorts, rarely survives prolonged perturbation. What we observe here is not decorative symmetry, but functional symmetry that interacts dynamically with rotation, torque, and momentum, music, exchange. The jets are not static features etched into ice. They are active processes, music, that should amplify instability, not suppress it. Yet, the system remains organized, oscillatory rather than chaotic, coherent rather than degrading. This pushes the interpretation away from music, passive growth, or random erosion and toward active structural balance. In scientific, music terms organization that persists in a hostile environment demands explanation. It does not point to answers by itself, but it narrows the field of viable questions. When an object repeatedly, music, chooses order, where chaos is cheaper, the universe is signaling that something about our assumptions may need revision. What makes 3I Atlas impossible to ignore is not any music single feature, but the discipline with which the data keeps refusing our expectations. Symmetry that should collapse does not collapse. Rotation that should destabilize does not destabilize. Jets that should wander remain anchored. Over weeks of thermal stress, changing illumination, and shifting geometry, the structure holds, repeats, and reveals an internal order that standard models struggle to absorb without stretching themselves thin. This does not mean we have an answer. It means we have reached the point where pretending the question is simple is no longer scientifically honest. The approaching January 22nd alignment strips away excuses. Projection effects, music fade. Geometry becomes cleaner. Weak structures grow visible. For the first time in this encounter, the object will show us its architecture with minimal distortion. If the triadic symmetry, music, persists under these conditions, if the oscillation remains coherent, if the jets maintain their spacing when the universe gives us its most revealing angle, then this stops being a curiosity and music becomes a constraint, a hard boundary on what explanations are still viable. Science advances not when music mysteries are solved, but when uncertainty collapses into a smaller, sharper set of possibilities. This is why this moment matters. Not because it confirms anything extraordinary, music, but because it forces precision, because it demands we follow the data, even when it leads away from comfort. In the next music hours, we are not looking for opinions, narratives, or speculation. We are waiting for geometry to answer geometry. And the universe, for once, music, is giving us a rare chance to look without shadows. If you want to be here when the next data, music drops, when the alignment reveals what holds and what breaks, make sure to music, like this video, so it reaches others who care about evidence over noise. Subscribe to stay with the analysis as it unfolds, and comment below what you think is the most conservative explanation that still fits music, all the data. Because the conversation is no longer about what we want 3i Atlas to be. It's about what the geometry allows it to be. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.